everyone, my name is Francesca and I'm an ESELA student in the 10th grade. I live in the Dominican Republic and I'd like to ask you a question. What would you do if you ended up with a bunch of rusty nails, screws, bolts, and washers and another myriad of rusted parts? This is exactly what I noticed was happening in my father's workshop. Over the years, he had collected a myriad of these rusted parts from old machinery that had been given to him by other people or he just found laying around. These parts are made out of steel. Steel is an alloy comprised of carbon and iron. Iron is made by removing all of the impurities and oxygen from iron ore, and when you combine it with carbon and some other elements, you get steel. Steel is the world's most important construction and engineering material. So I asked myself, how could I come up with an effective way to clean these rusted parts that was environmentally friendly and cost and time effective? So we need to start by asking ourselves, why does rust happen? Well, rust happens due to a process called oxidization. Oxidization happens when steel comes into contact with oxygen and humidity. Due to living in the Caribbean, we have to deal with oxidization a lot more because our country has a humid weather all year round. I started my research by looking at the internet and seeing what methods of cleaning rust I could find. I also wanted to make sure to keep the costs low and to maybe use items I had around the house to recycle them. From taking environmental science this year, I learned how important it is to keep the usage of resources at a minimum. Based on my research, I saw that people use abrasions and tumblers to clean rusted parts, but when I looked online, it turns out those machines were very expensive. So my hypothesis is that if I were to make a machine with recycled elements that uses vibration and an environmentally friendly abrasive medium, then I could massively clean rusted parts. These are the blueprints I made for the machine.
To attach the bundt cake pan correctly, I needed to make a wooden tower that could fit in the center of the pan. I needed some help from my dad to finish this step. It was then time to attach the tower to the base. After the tower was done, I drilled a hole into one of the fan's blades, attached it to the top wooden base, then adding the nut and the bolt to unbalance it, and finally adding the shock absorbers. Unbalancing the fan was important to get the vibrations we needed. The shock absorbers kept the vibrations concentrated on the top so the base wouldn't vibrate. After installing the recycled bundt cake mold using a screw and a washer, the machine was ready to be used.
The machine is comprised of one wooden base, 4 shock absorbers made of a silicone tube that are held by screws to the base, and then connected to a 12-volt computer fan. The fan was destabilized using a nut and a bolt that were attached to one of its blades to get the necessary vibration. This is the bolt right here. Then the fan is connected to a second wooden base, and in the middle I added a wooden tower to keep the recycled bundt cake mold in place. We keep it there with a screw and a bolt and a washer. The first abrasive medium we picked was cat litter. It was something that we saw worked online, and we figured that it would be something that some people could find in their households. The next medium I used was river sand. It was something that's common, and you can basically go outside and get it for free, and it's also environmentally friendly. The next medium I picked was steel grit. This was specifically made to be very abrasive, but it was a little bit expensive. Some of the parameters for the experiment were that I made sure that all the abrasive mediums weighed about the same amount as to not affect the vibration of the machine. I also picked out nails that were specifically rusted around the same amount so we could get fair results. After using each abrasive medium, I made sure to clean the molds just so there wouldn't be any cross-contamination between the mediums. For each abrasive medium, we made sure to keep the machine on for 24 hours for each one. I analyzed each one of the samples under a microscope using a 100 lens, a 450 lens, and a 900 lens.
Here we started to test out the machine and all the abrasive mediums using batches of rusted parts. For the sake of keeping some sort of uniformity in the experiment, we only tested the machine with rusted nails. The machine ran for 24 hours with each abrasive medium.
The results from the experiment show that number one, the machine does work and was able to clean the rusted parts. And number two, we found that cat litter was the least effective medium, followed up by the river sand that was the second best medium, and then the steel grit, which did the best job at cleaning the rusted parts.
With the first set of images to the left, we can see the control sample of the rusty nails that weren't cleaned. The following set shows the cat litter, then the river sand, and finally the steel grit. As you can see, we obtained the best results from the steel grit, followed by the river sand, and then the cat litter. All of these observations were done with a microscope using the zoom lenses shown on the left. These results prove my hypothesis. But wait, there's more.
We also had some additional findings, such as the river sand that we had having bits of iron in it. This can affect the results, therefore different types of river sand would have different results. Further research on the matter would be needed to be able to make a general statement on how well river sand works. I also realized during the experiment that the fan was moving clockwise while the abrasive medium was moving counterclockwise. We did some research on the matter, but we found out that there isn't much information on why exactly this happens, so we need to do some more research on this matter if we want to know why that is.
As we can see in this video, the fan is moving clockwise. I assumed that the abrasive medium inside the container would move in the same direction. However, in the slow motion second video, we can see the wave generated by the fan moving in one direction while the abrasive medium on the top moves counterclockwise. I have a hypothesis of why this happens, which could be related to the inertia of the particles when they jump and then fall back again, but that would need further research as we couldn't find information on the internet.